Okay, Algebra 2 fans, our topic for today, we are in section 3-8, dividing expressions containing complex numbers. And before we start, let me tell you your joke of the day. Did you hear about the guy who invented lifesavers? They say he made a mint. Okay, we're going to do a quick review here of, in section 1, recall rationalizing the denominator. When you divide by a radical, so in number 1, 5 divided by the square root of 3, this is not simplified if we leave the radical where it is. So what we have to do is we're going to multiply the top and the bottom of the fraction by the square root of 3. And the reason we're going to do that is this becomes 5 square root 3 on top, and the denominator, the square root of 3 times the square root of 3 is really the square root of 9. I can multiply those, but the square root of 9 is just 3. So what we get is 5 square root 3 over 3, and that's as far as we can go. That is now considered simplified because we don't have a radical in the denominator anymore. The square root is gone from the bottom. Now number 2 is a little bit more complicated because we have two terms. We have 1 plus the square root of 3. So what we need to do is we multiply by the conjugate. The conjugate would be 1 minus the square root of 3. And we have to do the same thing top and bottom. Now what happens in the top, we're going to distribute the 5. The 5 is going to multiply both of those. So 5 times 1 is 5. And this is 5 times, this is like a negative 1 in front of the square root of 3. So 5 times negative 1 is we get minus 5, and the square root of 3 is going to stay like it is. Okay, we can put those next to each other, but we cannot say 15 or square root 15. In the denominator, we are going to double distribute. Okay, so 1 plus square root 3 times 1 minus square root 3. First thing, we'll distribute the 1. So 1 times 1 is 1. 1 times negative 1 root 3 is negative 1 root 3, or minus 1 root 3. Then we're going to distribute the square root of 3. Okay, this is foiling or double distributing. The square root of 3 times 1 is positive square root 3, because it's a positive times a positive. Now the square root of 3 times the opposite of the square root of 3, a positive times a negative is a negative. Square root 3 times itself is square root of 9, but that's just 3. I'm not going to write the square root of 9, I'm immediately going to say that that's 3. Now what we have here, the two middle terms, we can add those up. Negative 1 root 3 plus 1 root 3. That adds up to 0 because they're opposites. And what we get here is 5 minus 5 square root 3 all over 1 subtract 3, which is negative 2. Last move I'm going to make here is I'm going to take this negative and I'm going to move it into the top. So if I do that, it's like I'm distributing a negative to both of these, and what we get is negative 5 plus 5 square root 3 over 2. Okay, or what you might see is they may pull the negative in front of the fraction, so the opposite of 5 minus 5 root 3 over 2. I don't like to do that because the negative looks like it's kind of in the middle of nowhere, so this is how I'm going to write it. Okay? The 1 plus square root 3 and the 1 minus square root 3 are what we call conjugates. They're the same two terms, except instead of being separated by addition, then they're separated by subtraction. Okay? And what happens when you multiply the conjugates, the radicals are eliminated. The middle terms get eliminated. Okay, same thing's happening with imaginary numbers, with complex numbers. 1 plus 2i times 1 minus 2i. Well, if I distribute, we would get 1 times 1. 1 times negative 2i is minus 2i. And then we distribute 2i times 1 is positive 2i. 2i times negative 2i, I multiply the 2 and the negative 2, I get minus 4. I times I is I squared. Now, Negative 2i plus 2i is 0. That's gone. Negative 4 times I squared, remember that remember that I squared is equal to negative 1. So I'm going to substitute a negative 1, and really what we get is 1. Negative 4 times negative 1 becomes positive 4. 1 plus 4 is 5. So in number 3, what we end up with is 5. 7 minus 6i times 7 plus 6i. I know that some of you like multiplying with a box, so I'm going to do it like a times table. 7 minus 6i, 7 plus 6i. And so as a times table, we'll do 7 times 7 is 49. 7 times 6i is 42i. Negative 6i times 7 is negative 42i. And when we multiply negative 6i times positive 6i, we get negative 36i squared. Now, 42i plus negative 42i is 0. That's gone. We get 49. Now, minus 36i squared is the same thing as minus 36 times negative 1. I squared is negative 1. So I'm going to substitute that, multiply here, this becomes positive, and 49 plus 36 equals 85. And what this is called, these are called complex conjugates. Complex conjugates. They have complex numbers. They have i's. All right, so what this leads to in the second section here, dividing complex numbers, number 4, 3 divided by I is not simplified. You cannot leave an I in the denominator of a fraction, just like you cannot leave a radical. Well, if I could make this I squared, it would be equal to negative 1. So I am going to multiply by what I call a fancy form of 1. In this case, it'll be I divided by I. When I say fancy form of 1, this divided by itself, anything divided by itself is 1. So I call this a fancy form of 1. Because really I'm taking 3 divided by I and just multiplying by, that's a 1. Okay, we get 3i on top. We get I squared on the bottom. I squared is negative 1. So we have 3i over negative 1, which is negative 3i. That's it. 7 divided by negative 2i. Now, I don't care about the negative 2. I need to just get rid of the I. So again, let's multiply by I over I. 7i, negative 2, I times I becomes I squared. Now that's negative 2 times negative 1. And a negative times a negative is a positive. So we get 7i over 2. Number 6 looks more complicated, but again, all we're going to do is multiply by I, top and bottom. Now in the top, you are going to distribute the I to the 3 plus 2i. So I put parentheses here. I times 3 is 3i. And then this is plus 2i squared. Remember, I times I is I squared. So plus 2i squared over 4i times I is 4i squared. Okay, we have 3i. Now this is 2 times negative 1. So I'm going to just write that as minus 2. 4i squared is 4 times negative 1, which is negative 4. And what I'll do is, again, I'm going to move that negative to the top, and I distribute it so it becomes negative 3i plus 2 over 4. Okay, and that is simplified. You know you're good as long as your i's are eliminated from the denominator, from the bottom. All right, so in number 7 here, what if we divide by a binomial here? We have two terms, 2 plus 3i. What we're going to do is we're going to multiply by the conjugate 2 minus 3i. The goal is to eliminate the i's. So in this case, we have to multiply by 2 things. We have to multiply by the conjugate. Multiplying by just regular I is not going to be enough. In the top, I'm going to distribute. We get 2 times 2, so we get 4 minus 6i over. In the bottom, we're going to FOIL or double distribute. That's 4 minus 6i plus 6i, 3i times 2. And then this is minus 9. 3 times negative 3 is minus 9i squared, I times I. So the numerator is 4 minus 6i. In the bottom, negative 6i plus 6i. What we get is 0 for that. And this becomes 4. Now that's minus 9i squared. Minus 9 times negative 1 becomes positive 9. And what we get is 4 minus 6i over 13. And that's it. That's as far as we go. We know we're good because the I is eliminated from the denominator. So you're kind of looking ahead. You're asking yourself, what can I multiply by that eliminates the I terms? And it's the conjugate. So number 8, the denominator is 3 plus I. Let's multiply by 3 minus I. And you have to multiply the top and the bottom by the same thing. Okay? I'm going to kind of speed this up a little bit here. So we get 6 minus 2i minus 18i plus, that becomes positive 6i squared. Okay, you can pause it and you can go through this yourself and then see if you and I get the same thing. In the denominator, 3 times 3 is 9. This will be minus 3i. And then this becomes plus 3i. That's good because these are opposites. They'll cancel. And then I times negative I is negative I squared. Okay, so that's going to cancel right there. In the numerator, what we have is 6. That's minus 20i. These are like terms. This becomes minus 6. 6 times negative 1. And in the denominator, we have 9. Now this is minus a negative 1. The opposite of a negative is a positive. So what we get here, 6 minus 6, that's 0 there. So we get negative 20i divided by 10, which actually reduces to negative 2i. All right, and that's as far as you go. So that actually reduced quite a bit there. In the last one, 7 divided by the square root of 2 minus 5i. This is interesting because we have a radical and an imaginary number in the same expression. So doesn't change what we're going to do. We're going to multiply by the conjugate, which is square root 2 plus 5i. Square root 2 plus 5i. Now in the numerator, we're going to distribute the 7. So we'll get 7 times root 2 is just 7 root 2. 7 times 5i is positive 35i. There's your numerator. Now the real work here is in the denominator. We're going to double distribute. The square root of 2 times itself is just 2. So that got rid of a radical there. The square root of 2 times 5i. Now, the 2 is under the radical, but the 5i is not. So all I can do is write 5i square root 2. That's it. When we distribute the negative 5i, again, we cannot multiply that by the 2 because the 2 is under the radical. So it's minus 5i square root 2. And then negative 5i times 5i. Negative 5 times 5 is minus 25. I times I is I squared. Okay, so let's simplify here. The top is okay, 7 square root 2 plus 35i. In the denominator, okay, check out positive 5i square root 2 minus 5i square root 2. That's 0. That actually adds up to 0. Okay, they're opposites. So what we get is 2 minus 25i squared. Now, that's negative 25 times negative 1, which becomes plus 25. And we can add those two numbers in the bottom. We get 7 square root 2 plus 35i over 27. And you have to think at the end here, look at your numbers 7, 35, and 27. Not the radical number, but everything else. We can't divide anything out of all three of these. So this is done. That's as far as you go, and that is the end of the notes.